Hi everyone, welcome to AWS Summit ASEAN. My name is Riza and I'm a Solutions Architect at Amazon Web Services. I'm going to introduce how to build an app that provides personalized recommendations for user-generated video by using AWS services. Today, many people can capture quality videos. People are generating their own content all the time. On the other hand, appetite for media consumption also keeps rising with expectation of enhanced user experience, such as getting personalized views with ever better, ever newer content recommendations. In fact, 63% of consumers today see personalization as the standard level of service. Market leaders are making investments in personalization to meet their customer expectations. However, current process of extracting relevant video metadata to produce recommendations is usually manual, time-consuming, and subjective. This process is expensive and not scalable for user-generated content, since people are producing content 24/7. This is where artificial intelligence can help. Now, I will show you a demo app that provides personalized recommendation for user-generated video. The recommendation is tailored to each user's taste and can adapt in real time in accordance to users' interaction. The app will also be able to automatically extract information from a video, making it possible to address cold start problem with new videos. Let's see the demo. This is my demo app. I'm going to log in as a user. Once logged in, I can see list of videos to watch. Now, let me log in as a second user. As you can see, the list of videos is different. This is because the video recommendations are personalized for each user based on a combination of users' past watching history and exploration for new content. For example, the app will recommend more technical videos to a user who previously watches a lot of technical videos. For new users without past watching history, the app will give generic recommendations in the form of the most popular videos. Let me add a new user to the database. Now I'm going to log in as this new user, and what we see here are the popular videos available. The app also can adapt in real time to a user's behavior. For example, let me simulate activity of watching a video until it's finished by moving the player control towards the end and do it for a couple of videos. Here in Developer Tools, you can see that whenever a user finishes watching a video, the app will record this activity to the backend. The app will then automatically learn and adapt the recommendation in real time. Refreshing the page, we can see that the list of recommended videos for this user has been adapted according to the user's activities. The app also has a video exploration feature to help new videos get exposure. Let's simulate generating content. I will upload a video. Alright, I can see that my video has been uploaded, and I will wait for a few minutes for the app to extract information from the video. Okay, we see the app has automatically extracted a lot of information about my video, like object detected, key phrases, and topic of the video. So even if no one has watched this video yet, the app can learn from this extracted information and use it to recommend this new video to some users. However, this learning is evaluated every 2 hours instead of real time. Skipping 2 hours ahead, we can see the new video is now included in the recommendations. That concludes the demo. Now let's see how to build the app. The core components of the app are the automatic metadata extractor and recommender system, both powered by AWS AI services. The metadata extractor will automatically extract information from a video uploaded by a user and pass it to the recommender system. The recommender system will use each user's watch history data and video metadata to provide personalized recommendations for each user. Let's zoom into the recommender system component that is powered by Amazon Personalize. To use Amazon Personalize, we will have to provide datasets as CSV files. The only mandatory data is user interaction data. We can also provide data about our videos and our users as separate files. Behind the scenes, Amazon Personalize automatically processes and inspects the data, identifies what is meaningful, selects the right machine learning algorithms, and trains and optimizes a personalized model that is customized to the data. Once we have our own model, we can interact with it using simple API calls. We can send new data like new videos or new events to Personalize and then make an API call to fetch recommendations that adapt to users' behavior in real time. Let's see demo of basic Amazon Personalize setup for a video recommendation use case. To begin, I have prepared a few CSV files that's required. These are the interactions data, videos data, and users data. The data are obtained from my database with slight modification using a custom script. In practice, it's recommended to have an ETL process to produce these files. For this demo, all these data are synthetic. Now, let's open Amazon Personalize in AWS Console and click the Get Started button. You can think of dataset group as a project, so dataset group name here is the same as project name. And then, choose the domain of your project. For example, I'll choose Video on Demand domain. Different domains have slightly different data requirements. Click Create. And first, we have to define interactions data. Here, you have to specify dataset name and create a schema. The schema tells Personalize how to parse your data, and it must match the content of your CSV files down to the order of the column. Once you are done, click Create. And on this page, we tell Personalize to actually import our CSV file from S3. If this is the first time you are using Personalize, you will also have to create a new IAM role for Personalize to use. I'll fill in the information and click Finish. The data import job will take a few minutes, and while waiting, you can repeat the process to import users and videos data. Once you have imported your dataset as indicated by active status in the job import table, you can begin creating the recommender using a machine learning model. There are different recommenders for different use cases. In this demo, I will only choose the recommender for topics for you to generate personalized recommendations for a specific user. There are some configurations that we can change too. For example, I can tell Personalize to recommend new items more frequently. Click Create Recommenders. Once the recommender is ready, you can use it to fetch recommendations. For example, I'm going to get recommendation for a given user ID. As you see, Personalize will return a list of item IDs, and you will need to fetch the other item attributes from your database. Amazon Personalize will automatically retrain the recommender every week to maintain the model performance. To capture real-time user interactions, we have to create event trackers. Go back to Overview menu, click Create Event Tracker, give a name, and once you click Next, you will have an event tracker for this project. Take note of the tracking ID because you will need it in your code. You can use this tracking ID to send data directly from your front-end app with AWS Amplify, or you can also send the data from your backend. That's all for the setup demo. Now let's go back to the presentation. Now that we have seen how to create the recommender component, let's see how we can automatically extract information from new videos to improve discovery of these new videos. When a video is uploaded, the app will use Amazon Recognition to extract labels based on visual cues, where label refers to objects, event, theme, or activity detected in the video. It will also try to detect celebrities in the video, if any. In parallel, the app will also process the audio from speech to text. The process starts with generating video transcription using Amazon Transcript, followed by standardizing the transcripts to English using Amazon Translate, and then detecting key phrases, overall sentiment, and topic that's most appropriate for the video using Amazon Comprehend. All of this information is then fed to the recommender system. Let's see how we can actually use the service. Label detection, celebrity recognition, and transcribe are asynchronous processes. We have to start an analysis job, monitor the job status, and fetch analysis result when the job is done. This is a simple implementation flow for a visual analysis job like label detection or celebrity recognition. Analysis jobs can be triggered with a simple API call. Once you get a job completed notification from SNS, you can simply make another API call to retrieve the result. The result will include confidence score, so you can easily filter out unconvincing results. And this is sample flow for a transcription job, which is very similar with previous flow. Amazon Transcribe will provide the results as a JSON file that contains the identified language code and the actual transcripts. You can get direct results for some API operations provided by Amazon Translate and Amazon Comprehend. However, to do topic classification, you have to build your own machine learning model with Amazon Comprehend custom classification. You can do this by providing sample sentences for each topic and building the model with a few clicks in the Comprehend console. This gives you an endpoint for you to classify your text via simple API calls. Here are some tips you may find useful. First, make sure to check the default quota, like maximum concurrent video recognition job. Next, make sure to check customization features provided by Amazon Translate and Amazon Transcribe that you can use to improve the service results. And lastly, have a look at our API docs to see what are the possible things you can do. Finally, let's quickly touch on some supporting components. You can use AWS Elemental Media Convert to do video transcoding for best watching experience and Amazon CloudFront to deliver your video with low latency. To speed up your development, you can use AWS Amplify, AWS Lambda, and Amazon DynamoDB to quickly set up a scalable and highly performant front-end and back-end system without provisioning any servers. To review, this is the overall full architecture diagram for the demo app. These are some additional resources that you can read on to help you get started with AWS AI services mentioned today. Here are some ideas on what you can try out to expand the demo app. You can try implementing A/B testing for personalized models with different configurations using Amazon CloudWatch evidently. Or maybe you can try to detect product and price from a promotion video using Amazon Recognition and Amazon Comprehend and build personalized shopping recommendation. Thank you for joining me. I hope this session has been helpful. We really appreciate your feedback, so please complete the session survey so we can serve you better in the future. Thanks for watching and have a nice day.